All right, and we're live. Okay, welcome back to another Mr.G EV Hangout. I really appreciate everybody being here. We got a huge roundtable discussion. Alex is the guest tonight. He's super popular. People jumped in, and he's from QC Charge. So hello, Alex.
Howdy.
All right, and so just give us a brief overview of QC Charge. What is that? And what are you doing there?
Yeah, so QC Charge originally started as Quick Charge Power a little over 10 years ago. Tony Williams started the company, and at the time we were building, he was building charging equipment for electric vehicles. So adapters, portable charging equipment, and eventually he started building DC fast charging kits for a few different cars as well. And not too long after that is kind of when I first got into the picture. So I started there just as a summer intern about 7 years ago, I think. And I was kind of doing some engineering stuff, doing like some sheet metal parts and stuff for one of the kits that we were working on for the Mercedes B-Class electric, actually. And then I went back to school after that first summer, and then the subsequent summer after that, I came back down again, and I ended up sticking around there in San Diego for the following about 5.5 years. So it's kind of been in the works for a little while that I've been wanting to move back up here to Oregon, and I finally made it work, and now I'm running the second QC Charge location. So it's my shop, independently owned, but it's a QC Charge shop. And yeah, so now I spend a lot of time working on other people's electric vehicles and trying to keep them on the road.
Oh, wow, that's really interesting. So the company started dealing with DC fast charging, and forgive me, was that for DIY or for to repair or to enhance the OEMs?
Yeah, so these were enhancements for OEM vehicles.
Oh.
The very first kit that Tony did was for the Toyota RAV4 EV, which was a car that was built in a partnership between Toyota and Tesla. So it's basically an early Tesla Model S powertrain stuck in a RAV4 body.
And was QC, oh, sorry, go ahead.
Oh yeah, so when that car was new, it didn't have any DC fast charging capability, and that was something that Tony purchased one of those cars new. And that was something that he felt the car was really missing. And so he decided to build his own fast charging kit for them. And I think probably close to 15% of the fleet of Toyota RAV4s have the kits on them now. And it allows them to use CHAdeMO DC fast charging, which these days is kind of dated. But it gets the job done. And it'll allow a RAV4 EV to charge from 20 to 80% in about 30 minutes.
Wow. Okay, so that's a big change. Now, forgive me, completely naive. Did he try and sell this to the OEM, or was this strictly aftermarket to individual owners and shops?
This is strictly an aftermarket thing, just to owners. And actually probably the first 150 kits or so, a lot of them Tony actually went and installed in the field. So when he first launched the kit, he actually did a cross-country road trip, stopping along the way all over the place and installing fast chargers in people's cars. We used to fly up to the Bay Area and install them, like we'd do, maybe half a dozen of them in a weekend.
Oh, wow, that's actually pretty cool. You guys were like a mobile service install upgrade for your EV, is that right?
Kind of. Doing it that way wasn't really a profitable thing to do, but we mainly did it because Tony liked the RAV4 so much. It's kind of the QC Charge mascot.
Okay.
And in the development for that kit and all, we learned a whole lot about the car, and we started to get questions from people asking if we could fix their RAV4 EVs when they started to have issues. And that was what got us completely started in the game of repairing cars, was the RAV4, because we had done the fast charging kits for him. So the very first drive unit that I ever rebuilt was actually out of a RAV4 EV shipped to us from Norway about 6 years ago. First one didn't go so well, but we learned from our mistakes, and now we rebuild couldn't even tell you how many I've personally had my hands on. Certainly hundreds, maybe even over 1,000.
How many Rav4s does Tony own these days? He's got a whole collection, right?
Well, there's always a ton of customer cars on site. They're like overflowing with cars there in San Diego right now. He personally he's got his original RAV4, and he might have a couple of other ones floating around that are kind of parts cars, and every once in a while he'll try and help a customer sell a car. Usually those aren't cars that actually get purchased, so he kind of just does it sort of on consignment, so to speak.
Okay. Wow. This is interesting. What a cool start to the QC story. And
I also sold some really nice charging extension cords that were J1772 extension cords. That's how I ran into quick charge to start with. So you have to park your car. You're 45 feet away from the nearest charging plug. You're not going to reach, and somebody in a nice car has blocked your spot. Well, you can use this extension cord to reach across and plug your car in. Your car thinks it's plugged directly into the charger. It has no idea that this extension cord is there, and it works great. It doesn't overheat. It doesn't break. Your car doesn't know any better. Yeah, it works awesome.
And, while we're doing this, I might as well introduce some of the people on the call here. We got Kevin Lieberman. How you doing?
Hi, good.
Kevin's doing software for Harley, but also does some volunteer work with the EVLC, and he's got his own electric car DIY. So he's got some project going on.
Yep, and I do the EV equipment garage sale for EV West, all of their used and secondhand general equipment I help sell for them. DC converters, chargers, etc.
Nice. We also got some newbies in the house. Chad's here, and we also have Chad. How you doing?
Good. How's it going?
All right.
Happy to be here.
He's thinking about doing a conversion. We got Sarah Lyons. She's right in the middle of a conversion, and she's there. And then we got Brian McCabe. He's also there. You go. Hey, Sarah. How you doing?
Good. Thanks.
All right. We got Homebrew. Jonathan Knight in the middle of the Thunderdome.
Hey there, Rob.
Jonathan.
Good to be here.
All right. Oh, we got Justin. Justin, where are you at with your conversion? Are you in the middle?
Yeah, still getting some battery boxes mounted. But yeah, slowly making progress.
Nice. And we have also Chris Rocky Hernandez. He's a aerospace engineer. Decided to take on. He's like, rocket ships, missiles. That's not enough. I want an electric car. So, that's pretty cool. So anyway, Alex, pretty cool. So now you're doing the repairs, but I'm just so curious. Did you do any gas to electric conversions of the RAV4? Is that an easy transition because of the architecture?
No, that's never anything that we did. And a lot of the components in the car, the car itself is really just a gas RAV4 body, but it does have certain adaptations made to it that would be difficult to duplicate on a gas RAV4. Like where the battery mounts on the bottom of the rocker panels, it has all the they're kind of like a nut insert, I guess, so to speak. They're not an insert, but they're like a captive nut that sits in there inside of a little welded cage. So that would be like one of the hardest things to duplicate.
Okay.
Yeah.
All right, that's fair. Okay. Now, so just to review, you basically had these RAV4s that were not DC charging capable, and you made them DC charging capable. How did that happen? I'm just so I'm sorry, that's a naive question. I'm just so curious. Did you literally just change the charger? Is that what happened?
No. So the way that it works is, the way that a DC fast charging works is you bypass the onboard charger completely. So you're going DC directly from the charging unit into the battery. So what it involves, and Tony would really be the person to talk to about this. He's more of the expert on that side of things. But essentially what it involves is
Well,
a
give us
contactor.
the layman's overview. Is fine with us. You know, we're just kind of navigating here.
Yeah, for sure. So basically what it involves is a contactor box. So you have a pair of contactors, big relays.
Oh.
And on one side of those contactors, you have the positive and negative leads for the JDMO kit going to the battery, right? So when the car is on, those leads are hot, they have voltage present. And then there's a circuit card in there that has all of the CAN data from the car side, so it can monitor the cell voltages in the battery and the temperatures and all that stuff. And then it can also do the CHAdeMO communication with the charger. So when you plug in the charger to the JDMO kit, it does all of the back and forth for the communication. And when everything's happy, it closes those contactors that connect the charge inlet to the battery. And that's the same way that it would work on any other car with DC fast charging, essentially. It's just an aftermarket add-on instead of something that would have been there from the factory.
Wild. Did anybody here have a Rav4, the electric Rav4? Anybody in the crowd?
I've met a lot of owners. In fact, I've met some that have had like people I've never known before. I've met them at chargers, and they got the hood popped and they got the CHAdeMO in there. And I talked to them. I'm like, hey, did you get that from QC Charge? And we started talking about it. Funny enough, the reason I popped out, Kevin reminded me, I actually bought this. This was my first hopping into level 2 charging with my 2017 Volt, because I was renting. I couldn't install a 240 volt. I couldn't install a 240 volt outlet in my place. I was like, man, I need to get my volts where I charge it in 6 hours instead of 12. And so this little box, which I think QC made it, but they at least sold it, takes 2 legs of 120.
Get out of here! I've been thinking about this all week.
And so, yeah, it would spit out NEMA. It was a 620, I think it was. So I could do 16 amps. Well, the Volt only, the Volt took 12, but I could do 12 amps at 240, which meant I could charge my Volt overnight. And then
Wait a minute. You got to understand, I've been dreaming about this all week. The whole week I've been thinking, why can't I just plug into a 110 on one side of the house and find the other phase on the other side of the house and then just plug in?
Well, that's what this box does. And it came with different, you could order it with different outlets. But again, it was limited to the amperage of, the actual 120 circuits, but it doubles your voltage. And so it basically gets you like low level 2 power. And I bought this back at QC Charge, probably back in 2018, maybe, I think. And I also bought my CHAdeMO Tesla adapter from Tony too.
Wow, this is so
It
cool.
was Dave, the EV doctor, I think, is the guy who made that thing, which has protections in there as well. So if one of your 120 volt outlets wired backwards, it won't blow up and things like that. And if you plug it into 2 outlets on the same phase, it won't blow up either. So,
Yeah. The bummer is it doesn't work with GFCI outlets.
Yeah.
Which garages have that. So I had to find a way to get 2 legs of 120 that weren't GFC. Anyway, but yeah, this is I got this from QC Charge. So I've been hanging. I met Alex a long time ago too, back at the shop, and also at the EV shows they used to put on. So anyway,
Alex,
Yeah, I forgot that you had even gotten one of those. Yeah, we used to be kind of a reseller for those things, and I don't think we've had them, for a long time. You may have even gotten one of the last ones that we ever sold.
it's kind of a hack. It's kind of a in between. I don't know if anybody remembers, but there used to be cassettes that would fit inside the 8-track player, and then you could still use the 8-track player. It's ridiculous, obviously. But my parents had one of those, and we used it a lot. We used it for years till we finally got a cassette player. It was ridiculous. Okay, that's interesting. Yeah, because so something that the electric car DIY people might not realize is that when you're just getting into this, you actually have to know something about the grid. Is that a fair statement, Alex, that you don't just do the car, but you might need to know a little bit about how grid power is delivered. What do you think of that?
For working on the cars?
Yeah, because you're charging, so you kind of got to know the difference between AC and DC, and the different legs in your house, and how to hook up your charger, stuff like that. So, because we're building an off-grid system at the high school right now, and we're making our own breaker. Just assembling it. And so you see the two bus bars that come down and kind of fork together on the breaker. And I was like, man, they got them out of phase. Wouldn't it be great if we could just, anyway, I'm just going off. It's basically because if you don't have a convenient way to charge and you go to your buddy's house and they don't have a charger, it'd be great to have these two plugs.
Yeah. I used this at my parents' house too. Like it was a hack because, not every, unfortunately in the US, I was kind of jealous of Europe. I still kind of am, that they have their regular outlets are 220. So they don't really have, level 1. And so, charging an EV in a meaningful amount of time, I was like, I got to do it. And then this is actually this got me on my path of making my own adapters. So I had to make an adapter to go from this to what the Volt EVLC could do, because the Volt and Bolt could do even though I had a 120 plug, it could take 2 legs of 120 and do 240. So because it was designed for other markets and stuff. So that was another hack, was being able to charge a Volt or a Bolt at 240 with the included EVLC. Anyway, so I'm nerding out here.
No, it's okay. I'm just excited because I've been thinking about that all week. Anyway, let's get back to the vehicles and the repairs. So, Alex, so at some point you guys transition to the new phase. What do you guys mostly do now? What's the top 3 most popular things that you guys work on now?
So of course we still do a ton of work on the Rav4 EV, and pretty much everybody that owns a Rav4 EV knows about us. We're like the go-to people for that. Even though it's such a limited number of cars and everything, there are only a little over 2,500 of them built, so it's a real limited market.
Yeah, if you went to your Toyota dealer with one of those, I think they would not know what to do. So
yeah, they'd look at you like you're an alien, especially if you're in a place that's not in California, which the Rav4 EVs, even though they were all originally sold in California, they've since made it all over the world. There's hundreds of them in places like Norway and Jordan and Ukraine, and of course they're all across the US as well. But yeah, so we do the big thing that most people know us for is rebuilding the Tesla large drive unit, which has its own host of problems, but the biggest one that causes the most issues is coolant intrusion. And that'll completely destroy a drive unit if it's not caught early. And usually the problem is that there's not really any good early warning signs before it destroys it, unless you perform a physical inspection of there's a sensor, it's basically the rotor speed sensor, the position sensor. And you can physically pull that out and check it and see if there's coolant on it. But most people don't know to check that or anything, and unfortunately, a lot of people's motors get destroyed. But actually,
there's a tragic flaw in these. Which cars does that affect? The Tesla cars?
Yeah, so the large drive unit was used in, of course, the Toyota Rav4 EV, the Mercedes B-Class electric, and then it was used in all rear-wheel drive and performance Model S and X from 2012 all the way through 2020.
Okay.
These motors will kill themselves if these seals are breached, which they do often, and there's no sign except your car makes bad noises and stops working. And these are the guys that know how to fix that problem. And if you catch it in time, it's repairable.
Exactly. And just recently, so we recently launched a new product that we actually eliminate the rotor seal completely, permanently fixes the problem.
Okay. Is that on your website?
It is. If you were to search on the website for, or even if you just went onto Google and typed in Tesla large drive unit rotor cooling delete, it would probably be the first thing that would pop up.
And this is a problem with just the large one, right? The small drive does not have this same problem.
Right. In comparison, the small drive units are practically bulletproof.
Wow. Wow. Maybe someone could put that in the chat for me and I'll pull it up. Pretty cool thing. How did you guys find that? Like, how did you get into that side of the business? Why would they come to you guys for that?
Well, so the main reason we started rebuilding those in the first place was, like I said, the RAV4. The RAV4 what really got us started in all of this. But we first started seeing RAV4s early on. It was mostly noise issues with the rotor bearings and stuff. That's a problem that all the earlier motors had. But as more and more of the cars started falling off of warranty, we started seeing more and more of the newer replacement motors that had been replaced under warranty failing. And we realized that most of the failures, especially the catastrophic failures, could be attributed to this coolant intrusion issue. And yeah, it's a really big problem that affects so many cars. And there's really only so many things that you can do about it, particularly if it gets to a point where it destroys the drive unit, which unfortunately happens all too often. But
yeah.
Oh, go ahead.
So does someone bring you their Tesla, or do they actually just ship you guys the unit, the drive unit?
More often than not, they send the whole car. But occasionally we do have people that'll pull a drive unit and send just the drive unit to us on a pallet to have it rebuilt. That does happen, especially from companies that do conversions. We've had a number of different companies that perform conversions on electric vehicles send us batches of drive units to have rebuilt before they use it in somebody's conversion.
Oh, I see. Okay. So they pulled a bunch of, is that we're looking on screen what's that, the sensor?
Yeah, so that's the rotor encoder sensor. That's what you can pull to physically check and see if there's the presence of coolant.
And is that have gear oil, and you're looking for the gear oil mixing with the coolant? Is that right?
Nope, it should be mostly dry. Sometimes you'll see a little bit of grease in there that comes out of the bearings, but apart from maybe a little bit of grease, there really shouldn't be anything in there. But if you see water, coolant, that's a bad sign.
Got it. Okay, and this one is
that's the other bad sign too.
What's that?
Or rust, that's the other bad sign. That's even worse. That means it's progressed to a point where the coolant has started to cause corrosion.
So now for the layman, what exactly is bad? I mean, most of us here probably know that water and electronics don't mix, but why specifically with these motors does the presence of water mean bad? Like, where does that water go?
So there's a few different places that it can go, but the first place it gets to is when it first starts to leak out of the seal. It's going to leak into the cavity where the actual encoder wheel is that sensor right there picks up on. And once it gets in there, it kind of has to work its way through the first rotor bearing. Sometimes that can start to cause a bit of a noise issue because it can cause some rust in the bearing, but not always. But once it makes its way past the bearing, it gets into the stator. So that's the part of the motor that has all the windings. And it's all encased in sort of a plasticized resin. And the coolant can soak into that resin and cause corrosion of the windings themselves, the copper windings.
Oh, wow.
And it can also cause rust on the outside surface of the rotor, and there's steel bars in the windings as well that poke out through that resin. So it can do a few things. It can cause a loss of high voltage isolation between the stator and the case. And it can also cause that rust buildup on the rotor and the steel bars in the stator, which can actually seize the motor up solid. Because, of course, as rust forms, it expands. So it literally squeezes the rotor into place. And then the next place that it can get to, which is kind of the worst case scenario, is if the coolant gets to the inverter. So that's all the power electronics in the motor. And, of course, when you expose electronics to water, that doesn't tend to end very well.
So now, just going through kind of our questions that we had, like top 3, most popular things that you have when it comes to motors, what else goes wrong or that you see that you guys deal with besides the Tesla water leakage problem? What's another popular thing of motor failure?
So that's the biggest motor failure thing. But other things that we do that are pretty common is we repair some battery issues. Real common one that we do a lot of, especially on, again, the RAV4 is actually battery contactors. I actually have one out here in the shop right now that just got a set of battery contactors. So
Okay.
those are the relays that connect the battery to the rest of the car when you go to start it.
All right.
Those are actually in the battery box. So is that true? Does it require dropping the battery for that?
That's correct. Yeah, it requires dropping the battery. And they're supposed to be in the battery because, of course, you don't want high voltage anywhere in the rest of the car when the car's not on for safety reasons.
Right.
So the contactors isolate the high voltage system from the rest of the car.
What's the symptom on your car if those have gone bad or are going bad?
They can have a few different symptoms. More often than not, though, you'll just end up having a situation where the car won't start. Sometimes they'll get to a point where they can maybe still start the car intermittently, or in the case of a lot of Model S's, when you have the contactors start to go bad, you'll get a power level reduced. So the car won't deliver as much power anymore because it's measuring the amount of resistance in those contactors, and it can actually measure how large of a difference in resistance, and it limits the power so that they don't heat up and actually weld the contactors.
Okay, so in that case, will you get a check engine light equivalent or something? Will the car tell you there's a problem?
You'll get some kind of error message. There's a couple different error messages that will be associated with it, but on most of the Tesla powered stuff, you'd get what's called a BMS W023.
And is that something visible to the customer without a scan tool, or that's only something you'd see with a scan tool?
In a Model S, you could see it without a scan tool. You just have to go into service mode. So on any of the Tesla cars, you can access service mode from the MCU, so the computer in the car. You can access it without any kind of scan equipment. It's pretty easy to do. But on a car like a RAV4, there's not any way to really see those codes without using the diagnostic equipment.
Now, I hope Chris Rocky Hernandez is paying attention, because I know that guy likes power, so he's probably going to put a Tesla drive unit in whatever.
Exactly. So I actually did have a question about that. So I'm looking at large drive unit and LDU in the car I'm looking at building, and I'm wondering if there's something I can do to look at the motor prior to integrating it into the vehicle, just as like a quick and dirty check to make sure it's healthy, or is there some kind of thing I can do? Like in a V8, for example, I would do like a compression check or something like that. Is there something I can do to an LDU to say this is a good motor or not?
Yeah, so the easiest thing that you can do is you can pull that rotor encoder sensor out and see if there's coolant on it. Now, that's not to say
Sorry,
Yeah.
Alex, Chris, he's got a video on how to do that on the QC Charge website. I'm going to pull it up while you're talking, Alex. Sorry about that. Go ahead.
Oh yeah, for sure. Yeah, there's actually, we have 3 different videos for it. So we show it on the 3 different cars to check it on: the Model S, the RAV4, and the Mercedes B-Class. But yeah, it's pretty simple. It's just one 10mm bolt and an electrical connector, which of course, if you're dealing with the drive unit that's already out of a car, all you got to do is just pull that one 10mm bolt and pull the sensor out and look at it. Of course, if you're buying a used drive unit, that's not to say if it's an unscrupulous seller, they could clean the speed sensor off where you won't see anything on it. But that is the best way to check to see if there's any coolant intrusion. There's other places that you can pull off the cover. Actually, right just a second ago where you had the video, there's an orange cover right in the center of the drive unit where the 3 phases are. You can try and pull that too, but usually if there's coolant there, it's probably too far gone. But what you can do is you can actually test the isolation on the 3 phases and see what that looks like. You kind of need a meter to do that, though.
What kind of meter do you need to check isolation between the 3 phases?
A mega ohmmeter. So it's essentially just like a regular multimeter, except it uses a much higher sampling voltage to measure the resistance. So in the case of a mega ohmmeter, testing one of these, you'd use a sampling voltage of 500 volts so that it can get a proper resistance reading.
So I just want to kind of hit pause in the conversation there to point out to the new people coming to this. For instance, like I'm going to pick on Chad for a sec. Chad's coming to this. I don't think Chad's a mechanic, but he's excited. He's interested. And so here's this simple test where you use an ohm meter, in this case, a mega ohm meter. And he just took my class where we went over the basics. Chad, had you done ohms or resistance before you took the class? You might have.
Yes, a little bit. Yeah.
Okay.
But it was a good refresher for me.
Yeah. So when you go into the EV conversion, if you're DIY or you're training and you want to be the next Alex, knowing how to take a reading like that, although seems basic, really fundamental, because you're going to need that to diagnose your car and look for things. So pretty cool. I think it's great that you pointed that out, Alex. And even though it's a mega ohm meter, maybe not everybody has that, but at least it should be known that the power electronics basics is kind of what you need to do something like this. But that's actually one of our questions coming up. Is what are the skills, the basic skills needed to do a conversion and to be in this industry? What would you say if you were to give us the top 5 skills right there?
Well, for one, a little bit of a knowledge of electronics is a big one, or at least kind of a knowledge of how, anything that's electric works. So you got to have some knowledge of your volts, ohms, amps, all that kind of stuff. You need to of course have some mechanical aptitude. It is still a car and it still has moving parts, and you kind of have to have a feel for how stuff comes apart and how to put it back together. Anybody can take something apart, but being able to put it back together the right way is a little bit of a skill. And it's a skill that can be learned, and some people are more apt to that than others too. Those are kind of 2 really good ones for sure.
Yeah. And so it's even learning how to work on a bicycle, learning how to work on small engines, doing your own brake jobs. These are all still part of the electric vehicle experience. Would you, right? Would you agree with that?
Yeah, I would say so. I mean, anything that can kind of get you any kind of practice into learning how to work on things definitely gets you a big step closer. And these days, there's actually, of course, training programs for doing this kind of thing. Back when I started doing this, 7 years ago, there were very few training programs, apart from maybe dealer-sponsored stuff for their own compliance cars and of course, Tesla. But there weren't really any independent training programs that you could go to at, say a community college or something. There were stuff for conversions in some limited quantities, but not really much for repairs on OEM cars. And of course, that's changed a lot. But yeah. So I'm kind of all self-taught on a lot of this stuff. I didn't have any kind of formal training when it comes to this, but I've always been really into cars ever since before I could even drive. And starting in high school is when I really started to get an interest in electric cars. And that's why I started working at QC Charge in the first place.
Nice. And just to riff on that for a sec, I do talk with a lot of people about shop classes. That's my day job. Did you have shop class growing up?
I didn't have an automotive shop class, but I did have I went to a really small high school in Southern Oregon. That didn't have a lot of resources available to students, but we did have a small welding class, just real basic. But the really big one that was actually what kind of got me into this stuff in the first place was originally I had planned to going to school to become an engineer. So I took a lot of actually CAD design classes using Solidworks when I was in high school. I did about a year and a half. I did three semesters of classes working with Solidworks.
Oh, Solidworks is great. People should, there's an updated competitor called Onshape, and it's all web-based. It's fantastic.
Yeah. Solidworks is super expensive, which is why I don't use it anymore. I actually use a product called Fusion 360 anymore, but I don't do nearly as much CAD as someone who's doing that as an actual trade thing. So
There's a $10 a month web version of SolidWorks for makers.
Oh, okay.
Oh.
There's like a maker version.
Yeah.
That's cool. So getting back to Rocky's question about diagnosing the motor, Rocky, did you have any more questions about what to do about your large drive unit?
So if you do find a little bit of unwanted water in there, is it safe to say that motor is probably not one you want to continue with?
It really depends. If you catch it early and it hasn't had a lot of coolant intrusion, it can be fine, but you probably need to at least take it apart and at a minimum clean it out, make sure you don't have anything major going on. Probably put at a minimum new rotor bearings in it. And maybe, a few other key things would be useful as well. But it really just depends on how severe it is. If you do see any kind of, especially if you're pulling one, from a wrecker, essentially, where you don't know if the motor was actually running, I would say that if you see coolant present on that speed sensor, the next thing that you want to do is pull the inverter cover off and see if any coolant made it to the inverter. And if that looks fine, then I would move on to checking the isolation and make sure the isolation is okay on the drive unit. If that's the case, then it should be recoverable, but you might have to rebuild it.
Let's say, so kind of a sort of a follow-up to Rocky and sort of like a general question for like first-time converters or like someone who's not that mechanically inclined, but they really want to just buy plug-and-play parts. Does QC Charge offer an inventory of certified inspected LDUs for sale, or do you know of a place that has a supply of LDUs that they can that's been inspected and or retrofitted with your new fix, so that I can have a working motor that I know is good? I don't have to worry about pulling the bearings and all that or taking apart.
Yeah, so we tend to have such a high demand for repair stuff that we don't tend to have a lot of inventory motors in stock. I actually do happen to have one inventory motor here that I just recently got a hold of. Shout out to Ray Johnson from the BMS U029 group on Facebook. It's actually his old motor that he had replaced. And it's still a good motor, but it did have coolant intrusion in it, so it needs to be rebuilt and everything. But yeah, typically though, we don't really have drive units in stock. But there are plenty of outfits that do sell drive units that, buy basically salvaged wrecked Teslas and they pull them apart and they sell the parts. There's a couple there's two of them in San Diego that I know of that do that. One that's pretty reputable and has a good reputation is called Autobahn Parts. I think that they usually test all their drive units before they send anything out. They don't rebuild them all, but they do check them to make sure they work. And I think they usually check them for coolant intrusion issues. And there's also an outfit over in Phoenix that does the same thing. They sell a lot of parts, and they have a pretty good reputation as well. I think that's EV Parts Solutions. And then of course, all of you have your retailers that sell parts specifically for electric conversion. So your companies like EV West and Electric GT and all these types of places that sell parts. A lot of them, check the motors out before they sell them, of course.
Okay. John, did you have a question still there?
Yeah, his hand has been raised a while. I didn't know if he already asked his question.
Is John there?
No, I'm good. I think I left my hand up.
Oh, okay. So Alex, I see on your YouTube channel that there is a Toyota RAV4 and a large drive unit in the same thumbnail. I can't even imagine what's happening there. Are you really putting Tesla large drive units into the RAV4s? Or am I naive? Is that how it was?
That's how it was originally, yeah. But it's a model.
Here.
it's a modified version of the large drive unit. So in the early days when these cars were built, when Toyota did this partnership with Tesla, that's the only motor that Tesla built was the large drive unit. So it's a detuned version. So it uses a base inverter that's even further down tuned. So it has less power than Model S. But the really big changes are mechanically. The motor is actually flipped around backwards and they run it in reverse. So it actually has reverse cut gear set and it has a parking pole added into it, which are things that the Model S doesn't have.
Oh my God, I had no idea. So could you, is it, I mean, it must be a pretty powerful vehicle. I just didn't realize the RAV4s were set up like that.
They definitely get out of their own way. Actually, I think there's a video on there of a RAV4 doing a burnout. But yeah, on paper, they advertised them as having about 150 horsepower, I think. But if you do the math on the amperage output and everything, it's clearly way more than that. It's more like 200 to 250 horsepower.
Whoa,
Yeah,
that's
they have
amazing.
Sir.
Pretty cool. So, now okay, let's go over to batteries. But if people have questions, go ahead and just interrupt us and ask your question. Just let us know.
I was going to say before we transition too much, while we're still on motors, Alex, do you know anybody that's converted a RAV4 EV to dual motor / all-wheel drive? Because they're all two-wheel drive, right?
Right. Yeah, they're all front-wheel drive. I don't know of anybody that's done that. I do know that it's something that we had thought about previously, but we would probably do it in conjunction with other modifications. So one of these days, we're hoping to have a battery swap option for the RAV4 to give it more capacity. We would probably use like the older 2170 style short range Model 3 battery. But that's a back burner project that, I mean, who knows if we'll be able to get it done. One of these days, maybe, but it's low on the list of priorities right now.
Yeah, and probably another low list, but has anyone with an original RAV4 EV ever reached out to you, like the old nickel cadmium ones? I know there's much less of those than there were of the Tesla RAV4s, right?
Right, yeah. I have worked on one. And it was actually one, I don't remember what their official name for it was, but it's essentially the BMS. Had a problem on this car. And the car would still run, but it wouldn't charge anymore. So I ended up, the owner had actually already kind of diagnosed the issue themselves. They'd sourced their own part. They just needed us to pull the pack and replace it for them because they didn't have the facilities to do that. And actually they ended up getting, there's two different versions of that part. They ended up getting the wrong version. So they ended up having to order the other version for us to get it put back together. But yeah, we ended up dropping the pack out of it. I think there's actually a video on that car on the QC Charge channel as well, but there wasn't any video where we had the pack out or anything. I kind of did a video where I compared the old one to the new one.
Very cool. Yeah, that the original RAV4 has always kind of had a place in my heart, and I have a kind of a dream of like modernizing the original RAV4 EV, but that's a much more niche project. But Ron, you wanted to get to batteries, unless there's any other questions from the group here?
I just had one other really quick question. I thought I heard you gloss over a statement that said something to the effect of that the small drive units are pretty much bulletproof compared to the large drive units. Did I hear you right?
Yeah. So the large drive unit the small drive units are oil cooled instead of water cooled like the large drive unit is. So they don't have any seals or anything to fail in terms of a coolant intrusion issue. That's not to say that they don't ever fail, but on the broad scope, they're far, far more reliable than the large drive unit is.
They're still like 400 horsepower or something crazy like that. So
yeah, I think you can probably get about 350 horsepower or something like that out of a small drive unit. So if you're not looking for crazy huge amounts of power, it's perfectly adequate. And actually my personal daily driver is a dual motor S. So that has the small drive units front and rear. And my rear drive unit in that car is still original at over 450,000 miles. So.
And what about your battery pack? Is that the original battery pack?
No, that was replaced probably at about 250,000 miles based on what
Oh,
I
that's
learned.
pretty good though.
Yeah. So the current battery has about 200,000 miles on it, and it's got about 85, 86% capacity.
Oh yeah, that reminds me. I think the last time I saw you in person was at that Mach-E hangout in Carlsbad. You had your Model S there with, I think your today's mileage was what, 450,000 miles back
Yeah,
then?
something like that.
Yeah, that's crazy, man.
Well, that's giving me hope because I bought a Model Y and I really like it. And if the battery ever goes and I'm out of warranty, which is very likely because not likely that the battery will fail, but it's likely that I'll be out of warranty pretty quickly because I've already put 30,000 miles on it in just about 13 months.
Yeah.
I crank this thing. I drive this thing everywhere. It's fantastic. But I would like to know, the skills that it takes to drop that battery. And kind of skipping ahead, I'm going to get to Jonathan's question in a sec, but when you drop a battery pack on a Model S, it is kind of like changing the charger on your battery or the battery on a drill battery. It's the bottom of it just pockets out, right? But when you change the battery on a Model Y, isn't that the entire floor, including the seats and upholstery?
That depends if it's an Austin build structural pack. The ones from Fremont drop out similar to a Model S, but Alex probably knows a little bit more specific than that.
Oh.
Yeah, that's pretty much it. It really just depends on which configuration. Really, the only ones that I know of specifically are the ones that were built in Texas with the 4680 battery. If it's anything other than that, then it has just a regular battery, kind of like a Model S. There's a few extra steps because on the Model S, they made it where all of the electrical connectors and the coolant lines all self-disconnect. On the Model 3 and Model Y and stuff, you actually have to physically disconnect all that stuff before you drop the pack. But more or less, it's pretty much the same as any other car to drop the pack out of it.
Oh, okay. Jonathan, you got a question?
Yeah, I was just going to shout out the original RAV4 because this is awesome talking about it. That was the first EV I ever drove. I rented it probably around 2000 when I was in LA. I rented it for a weekend and just loved driving all over LA in it. And I don't know, basically that's the thing that made me fall in love with EVs to begin with.
It had those paddle chargers, right? It didn't have a J1772, but this funky paddle thing you'd have to stick in there to charge it.
Pretty much all the 90s and early 2000s EVs had to use that paddle charger, right?
Some cars didn't. So I actually used to have two Ford Ranger EVs, and those used, they call it an AVCON connector. And that's actually basically, it was J1772, but not with the connector that we know today. It's the same communication. So you can actually make an adapter that goes between the two that doesn't have to do any adaptation communication-wise. It's just the connector itself is different. It's kind of a big rectangular thing that you push in and then you turn it, you push it down. They call it an AVCON connector.
Okay, so it was that or the paddle, because I remember the EV1 had the paddle, right?
Yep.
And the Honda also had the paddle, I think.
I think so. I think the EV Plus, the EV1, and the RAV4 all used the paddle.
I remember when I would, the first year I had my Chevy Volt in 2016, the Mission Valley charger, where there's now a charge point, the old paddle charger was still there in 2017. That was crazy. I felt like I was looking at I went back in time almost 20 years. But anyway,
when we
paddle
were
charger, it was like a blade.
Oh, what's
Sorry.
that?
It was like a blade. What's the paddle charger?
It's kind of like a blade. It's sort of a big plastic rectangle that's rounded on the end, and it has a handle where the cable's attached on the other end, and it slots in kind of like an 8-track tape.
yeah,
It slots in to the front of the car.
They're
Yeah, there
also-
you go. That's what they look like.
inductive, right? Weren't they inductive charging?
Right, it's inductive. It doesn't have any external conductive contacts on it. They're inductive.
Yeah.
And
Whoa.
there have been problems with them before where they get hot and they actually melt things. So you kind of have to be a little bit careful with them on the older cars. You have to make sure everything's good and clean. But I actually saw one of those chargers when we were up in San Luis Obispo for Tesla Takeover this summer.
Nice. Nice.
No kidding. So cool. What good stuff going on here. Let me say hi to Tom. How's it going, Tom Summers? The excitable Tom Summers is in the
Hey,
house.
man.
All right.
Hey guys, good to see you. Hi Alex. I understand you're operating out of up north now.
Yep, I've got a shop up here in the Portland area now.
Wow.
Nice.
So are you? Is that like you're still QC Charge? You guys are just franchising?
Yep, that's essentially the case. So I'm sort of the guinea pig, so to speak. So I'm sort of the first franchise location for QC Charge.
Oh man, I love it, man. That just means that you're just we're more legitimate than ever. So that's great news. It's good to see all you guys. Yeah, tonight. I
Sounds
tuned
like-
in late, but yeah.
Sounds like
That's all
Tom and
right.
I need to do a road trip to go see the shop.
Yeah, maybe so.
We're definitely. I want to kill a couple of birds up north. I want to stop and see the folks in Santa Rosa that you had on the other week, Ron. They've reached out to us.
Thunderstruck Motors.
Oh yeah.
Yeah. What is it? Switch?
Oh, and Switch.
Yeah,
Switch Lab.
Thunderstruck makes some really great products.
Mm-hmm.
I think that we're at a point where the learning center is ready to grow. If I may say so.
Cool. Good. The Electric Vehicle Learning Center. Yeah, and there's a class coming up. What is it, this weekend?
This weekend, EV 101, March 1st, 2nd, and 3rd, baby. I was going to plug that later in the episode, but yeah.
Yeah, and not only that, I'm going to go up there and pick up El Rayo and exhibit the Brazilian bus at Snapdragon Stadium. There's a big STEM school event being held at the same time. Yeah, a lot of stuff going on, man. It's really good to be in this scene now.
Nice. Yeah, so this is coming up this weekend, and yeah, it's very high detail, a lot of stuff covered. Chad, you were in this class. What'd you get out of it, man?
Yeah, it was good. It was my very, very first intro into anything EV conversion. So it was a really good kind of baseline overview for me. I would highly recommend to anybody who's interested.
And Jonathan Knight was there, I think, right? Jonathan, you took the class as well?
Yeah, I took the class last summer. Had a great time.
Nice. And also Sarah Lyons.
Yeah, I think Sarah had to take off, but yeah, she's yeah.
Okay. So I think I want to get into batteries, Alex. Can you give us like the top 3 most problematic, problems that you guys come across when it comes to batteries?
Yeah, so we tend to do a fair number of contactor replacements. I kind of touched on that a little bit earlier.
Okay.
And like I said, I actually have a car out in the shop right now that I'm kind of in the middle of doing that on.
Oh yeah.
And on some of the older cars, on the Model S's and such, we're starting to see more and more issues with the batteries on those, where they're starting to develop cell imbalances and things like that. And there's actually a really, really great community. There's a group on Facebook where there's tons of people that kind of contribute to finding different solutions for these issues. It's called BMS U029/U018. Those are kind of the 2 codes that pop up when you have one of these issues.
Are those Model S specific codes? Because I know personally, we can talk about this later, but I've had, we can talk about the Model Y, 3Y batteries.
Yeah, so that's mainly a Model S and Model X kind of specific code. I think that there's other codes that pop up when you have an imbalance on Model 3 and Y, if I'm not mistaken. But I haven't dealt with a lot of Model 3 and Y cars because most of them are still under warranty. So I haven't dealt with a ton of those cars at this point.
Now, people should stay tuned because we're going to do a little bit of a shop tour if Alex doesn't mind. Right, Alex?
Yeah, for sure.
Okay. But we'll get to that. And but just to for the people who are new to this, let's say for instance Chad or any of the other people just coming into this, and Brian McCabe, when you say contactor, I just want to emphasize that they might not know what that is, but that is basically just a big relay. And
it's basically just a big relay that's inside of the battery.
Yeah. And so that's like your high voltage is pretty much disconnected. When you walk up to your Tesla, or electric vehicle, when you go to unlock that car, if you just listen for a sec, you're going to open the door, but you're going to hear click.
Ka-dunk.
And that's your contactor closing. So I just want to emphasize that for the people that are just learning it right now. Cool. So now what happens to these contactors? Why do they fail? And how do they fail?
And how is it separate from a balancing problem?
Oh yeah.
Yeah. So on the older Model S and a lot of the other early Tesla powered cars, like the RAV4 and the Mercedes and such, they used a contactors that were built by a company called Tyco, otherwise known as TE. And those contactors are maybe not the highest quality. They usually tend to burn out the coils, and sometimes they have issues with the contacts themselves too. And usually it seems to be right in the neighborhood of about 100,000 miles when they fail. And usually when we replace them, we actually replace them with a gigavac contactor, which they tend to be a lot higher quality. And they last a bit longer. And the later revision batteries, actually, they switched to the gigavac contactors for that reason.
Yeah, I think Gigavac is what Revolt's using in their contactor box now.
Yep, and that's what the JDMO uses as well as the gigavac contactors, the GV200.
It's funny that, to hear about what the OEMs are doing, because I've seen these in conversions for years. And but then to hear that the OEMs are using the Gigavac or a Tyco as well, it's amazing the access you have as a DIYer. It's just so fun because you get to get into the engineering of a car.
Fun story about Gigavac. It was actually started by a group of engineers that worked at Tyco, and they split off and started their own company. It was based in Santa Barbara, I think, was where they were based out of. And I think just maybe a couple years ago, they sold to some big conglomerate thing, Sensata. So now Sensata owns Gigavac, I think.
That's amazing.
They built some high quality stuff.
Man, that is a tale old as times.
And the thing about people leaving a company and starting their own. The thing that I think that probably is not emphasized enough in just young people getting into this, or even someone who's just starting out, is that the DIYer is super important, because they are the person that's going to figure this stuff out. And they're going to, and eventually provide solutions, and it's is that kind of, Tony's story is he basically, he needed a solution and then he created QC based on that. Is that right?
Yeah, I mean, pretty much. The very first product that actually started QC Charge was a product called the JESLA. And so that was another thing about the RAV4 when it came out, is it was the only non-Tesla car that could charge at 40 amps on level 2. And there were basically no companies that made a portable level 2 charger that could do 40 amps. So Tony decided to buy one of these Tesla mobile connectors, cut the plug off, and stick a J1772 plug on it, and try and use it to charge the RAV4. He didn't know if it would work. He figured it, at a minimum, it would probably work with the RAV4 because it used the Tesla charger. So he wasn't sure if it used a different communication method or not, and it worked. So after he did that, he decided, well, maybe if I make 10 more and sell them, I can pay for the one that I made for myself. So he made 10 more and sold them immediately. And then he kind of realized he sort of had a thing going. And yeah, I think it started in like the hallway in his house, and then it moved to like a spare room and then the garage. And yeah, it all kind of built from there. But that was the very first product was the JESLA.
That's amazing. So let's get into the imbalance, because I mean, and this is like a big fear of a lot of people. And I can reference, the class I just taught over the weekend. Chad, we did a series charging your pack in series. Why does it need to be balanced? These things are important. And so what happens with an unbalanced pack? What's the first sign, and how do you get to it? Or you could address this how you want to, but can you talk about the unbalanced pack?
Well, I definitely want to know a lot about this, because I've had 2 battery replacements on my Model Y, and we could talk off screen more about this, but I'm still to this day, I don't know if it was a battery imbalance or if it was an actual bad cell or both. So I want to hear tons about this, Alex.
Right, yeah. So a battery imbalance can be caused by a bad cell. And a lot of the time on these older cars, that can kind of be the culprit, is basically just one cell or a small number of cells that essentially go parasitic. And they kind of create a draw on the cells around them and create this imbalance. And the BMS is really sensitive to these kind of things. If you get an imbalance, it's more than, maybe 10 or 20 millivolts, it's going to start having a problem. And particularly what really causes that is when the BMS starts to measure differences in the amount of capacity that each of the bricks have. And a brick is a group of cells that are all in parallel with each other, right? So you have the group of cells that are in parallel, and then those are series together to make your pack voltage.
And
So
Ron, sorry.
Yeah.
I was just going to say, in a Model S pack, and at least in the older Model S's, the way the modules are built is they have 6 groups of cells in series, and each of those series groups, which they call a brick, each have, I think it's 73 cells. So you have 73 times 6 is 444 cells, and then you have however many modules in the pack. There's either
I think it's 74, but yeah, it doesn't matter.
Oh, 74. Yeah, it might be 74.
So Ron, when we were doing the summer bus, we were talking about trying to keep the pack within 5 millivolts, right?
I can't remember, but that's a Kevin question probably. But we had an issue over the summer.
The closer, the better, basically, is the deal. But the tolerance is set up in the BMS. When the BMS decides they're too far out, it'll tell the car to stop driving.
Right. The issue we had over the summer was wild. But why don't we let Alex tell us more about this, and then we'll kind of give you we had a tricky situation where the voltage looked okay, but when you charged it, it would charge it within what you call a brick. I actually didn't know that we call it that. The brick, which is the 74 in parallel, would be instantly hit the roof and shut off the charger. And so we had a low capacity problem.
Yeah, you must have had a low capacity problem on that brick. But yeah, I mean, sometimes it can be one cell, or sometimes it can be a group of a whole bunch of cells. And I mean, yeah, that's essentially what can cause problems. There's other problems that the older packs can have too on the Model S besides those kind of problems. And the other common issues they can have are problems with the electronics. So each of the modules has its own little individual monitoring board that all talks to a sort of a master control board that controls all the rest of the boards. So each module has its own board, and then those are all connected to the master board. But sometimes those module level boards can have problems. And then other issues that happen on the older packs, particularly on the oldest Model S's, is water intrusion.
Yeah.
And there's a few different things that can cause that. Sometimes there's little vents on the bottom of the pack that can go bad, that can let water in from the bottom. But on the older cars, they also have Sometimes they have issues with actually the AC condensation pooling up on the top of the pack and rusting out either the fuse cover or getting in around the bolts, or one of those kind of problems and causing a water intrusion issue, which if you have too much water intrusion, I mean, the pack is just not salvageable at that point. They're not really safe when you get a bunch of water into them.
Yeah, there's a pretty prominent viral post from this guy in Canada that had like a 2013, maybe 2014 Model S, and he was super mad, and he went super viral because he was out of warranty, but because he had one of the, it was that exact problem, I believe, of the AC dripping down on top of his pack, and he was mad because Tesla like knew about it, and he still would be charged like $20,000 for a new pack from Tesla. So I think that kind of brings up a question of like, so out of warranty, what kind of prices and services are we looking at with like QC Charge being able to service, or what are you able to service with the out of warranty pack, and what kind of costs are associated with that?
Yeah, so I mean, it kind of depends on what the issue is, right? So if you have a water intrusion issue where you've affected a bunch of the modules in the pack, it's kind of not really salvageable at that point, especially not for reuse in the car, because it's just going to have issues again later down the road and could be a safety problem too. So in that kind of situation, you're looking at probably a pack replacement. And there's different options for that. There's used packs. You can get a used pack from a wrecked car. There's companies that recondition packs, or you can even get a new pack from Tesla. That's an option too. I actually have a parts account with Tesla. Pretty much anybody that has a business can create a parts account with Tesla, and you can actually purchase parts from them, including a battery pack.
Wait, kid, I didn't know that. I thought they're only selling it themselves.
So you can buy a new battery pack from Tesla, but they won't sell you a remanufactured battery pack.
Because they're being all put into all the warranty repairs. That I'm pretty sure that's why. Because when you get a new battery warranty from Tesla, it's most of like 99% of the time they give you a remanufactured pack.
Yep, that's usually what happens. It's pretty rare that you get a new battery if you're under warranty. Sometimes they do, but more often than not, it's a remanufactured pack. And yeah. I know that unlike the Model S batteries, the older ones, the remanufactured packs don't necessarily have the greatest track record. Some people have had them last for a long time with no issues, and other people have issues with them fairly quickly. So there's kind of a little bit of there's a little bit of controversy around that.
Now, let's say you're doing a conversion. And let me just say this, Talik, I feel for you because I got the Model Y, and I'm probably going to be out of warranty in the next couple of years. So we'll be in the same boat soon. I want to learn from Alex here about what to look for, how to know about it, because I'll just do my own pack if I can. I'm not gonna, So yeah, exactly. I want to know how to do this stuff. So, so you got people like Jonathan. You got people like Chris in the call. Chad's here. There's a lot of people here. Brian McCabe, Jonathan Knight, Justin. There's a lot of people here that will probably, and also Tom Summers. There's a lot of people here that are using Tesla modules in their conversion. What are some of the symptoms or things they should look for? If they have a pack, can they check to see if it has all the, if there's these typical things like the water problem, or in our case, over the summer, we had this low capacity problem. How do you diagnose this type of stuff?
Yeah, so the BMS on like the OEM BMS is pretty advanced in what it can do. It can measure the capacity of the bricks and everything pretty accurately. And that's how they flag these problems. If they notice a difference in capacity, even if there's not a huge imbalance and the BMS is able to keep it in check, they can tell if there's a big enough difference in capacity that they'll flag an issue. Usually if there's that big of a capacity difference, the BMS won't really be able to keep up with the balancing, and you'll have an imbalance because of that. But it also depends on where in the state of charge curve you are for the pack, and there's some other factors that go along with that. But yeah.
Justin's got a question. Is there a rule of thumb, internal resistance we can, sorry, I didn't get finished reading it before it went away. Justin, you can ask your question. I'll just read it though. Sure. Is there a rule of thumb internal resistance we can measure on each module?
Yeah, so there's not really an internal resistance reading that you can get on the module. I mean, you can measure for, there's not really any way that you can measure, well, I guess there are ways that you can measure internal resistance, but you'd have to have some testing equipment to do that. Yeah, that's getting a little bit complicated, but there are ways that you can do that. What you'd probably have to do is do kind of a charge and discharge test. So you have to test the module, discharge it near empty, then recharge it, and maybe even do that multiple times and see if you get any kind of cell imbalances. And that'll kind of tell you where you're at in terms of pack balance. That kind of gives you the best idea.
That reminds me of like what Jehu Garcia does with all his harvested 18650s. Is it kind of like along that same lines? That's what it sounds like to me.
Right, yeah. Like if you started with a pack, like let's say you took a module and it's at a low state of charge, say it's at 10 or 20% when you start with it, and the cells are pretty evenly balanced. If you charge it up all the way and one of the bricks has less capacity than the others, that one's going to hit the high voltage cutoff threshold before the rest of them will. And then as you discharge it, it has less capacity, so then it's going to drift down again, and you're kind of going to get that give and take back and forth, and eventually it'll get to a point where, you know, you'll start to see a bigger and bigger voltage imbalance if it doesn't have the same amount of capacity.
So I've also heard that it's not a good idea to mix and match modules from different packs. Is that true?
Yeah, that's definitely the case. And that's also one of the reasons why you can't really feasibly do a module replacement on a Model S battery. You can't, if you have a bad module, you can't take it out and put another one in, because it's almost impossible to find two modules that are going to be the exact same capacity. Because every battery has led a different lifespan. They've been charged and discharged differently. They have different amounts of charge and discharge cycles on them. They've had different types of temperature cycles. There's all sorts of different things that affect the discharge curve once, you know, as the battery ages. And you can try to find modules that match, but it's a little bit like trying to find a needle in a haystack to try and find modules from different packs that fit together, so to speak.
Is that pretty much what Tesla's doing when they do a remanufacture pack? They're doing their best to match up modules.
I don't know that anybody outside of Tesla really has the answer to that question. So I
feel like that'd be really hard to do.
That I don't really have an answer to, and I don't know that anybody else really does. There's been some speculation on that, whether that's what they're doing, or if they're on packs that maybe only have electronic issues, they're fixing those ones, fixing the electronic issues and putting them back together. Or maybe on packs where they have a module problem, maybe they're eliminating modules and making it into a smaller pack, which there's actually third-party companies that do that now. There's a company called Resell. They're based out of, I think they're based out of Texas. And they actually do that as a service for Model S packs. If you have, say, an 85 kilowatt hour pack that has a bad module, they can remove two modules and make it a 70 kilowatt hour pack. And I think they're working on a kit where they're going to offer that to shops so that they can do that as well. They have a pretty comprehensive diagnostic capability, and yeah, they're definitely experts on the battery stuff.
Okay, totally naive question. What is the deal? How would they do that without changing the voltage?
You do change the voltage. But the cars are set up that way. So that's the difference between, say, like my car's a Model S, it's a 70D. So it's a 14 module pack, whereas an 85 pack is a 16 module pack. That's how they change the capacity between the long range and short range models on the Model S's.
So do you have lower voltage, top voltage?
Yep. So my pack is only an 84S pack.
Oh, so what's the bottom? What's the bottom voltage that you could be at?
The low end voltage would be somewhere in the mid to high 200s. Let's see if I can.
Oh, wait, that opens the door for a lot of possibilities.
Yeah,
when you're doing
probably somewhere in the low to mid 200s. Like, I don't know exactly off the top of my head what the low voltage cutoff is.
That's okay. If you
Probably,
give us a
probably about
ballpark.
2.65, 2.7 times 84. 2.7 would be 226. I mean, that would be running the pack down to dead.
Oh,
But
3.7, you mean, right?
3.7 is nominal.
Oh, okay, okay.
I mean, for a lot of applications, you don't really want to run them below 3 volts. But if you run them really far down, you can push 2.5, but that's like you're pushing brick territory there. Usually,
what would be
most cars have a low voltage cutoff in the high, 2.7, 2.8, something like that.
Oh, I see. So, but what I'm getting at is, what would be the minimum amount of modules in a custom application? 14, or could you go smaller?
You can go small. It depends on what voltage setup you're running. But if you want to run a high voltage like a Tesla drive unit, pretty much the minimum you have to do is an 84S system. You can't really go much smaller than that.
Yeah, that's kind of what Revolt did with Tim Allen's. It was originally set up to be a 150 volt system, and so they paralleled some of the packs a certain way. And then when Revolt got it, they added I think 1 or 2 modules to make it the 400 volt system for the large drive unit.
Right. Yeah. A lot of off-the-shelf systems that you can buy run a lower voltage, like the Hyper 9 motors and a lot of the brushed motors. AC, your HP EVS like AC50 and that kind of stuff, they're in that lower voltage range, right? Your 100 to 150 volts. But once you get into running something like a Tesla drive unit or something like that, you have to run those higher voltage systems where you're in that 300 to 400 volt range.
Okay. But I imagine if you're taking a car that had 16 modules and you're putting 14 in it, they must have to change some of the electronics too, so the BMS doesn't freak out that it doesn't see those other 2 modules. Besides the voltage difference, it's got to be convinced that it's okay that 2 of those modules that used to be in there aren't there anymore.
That's if you're using the original BMS, right?
Yeah.
A lot of these conversions, you end up using like an AEM BMS or
right. I'm not talking about the conversions and the stock cars that they're removing bad modules and making the cars, putting them back on the road again. They're reprogramming.
Right. Yeah. You have to physically change the firmware in the BMS, which typically there's not really a good way to rewrite the firmware on it. So usually what you'd probably have to do is buy another BMS that has the correct firmware on it. If you were doing this as like a DIY, trying to piece something together, that's probably what you'd have to do. But yeah, you'd have to put in a loop, kind of a bypass loop for the serial communication between the slave boards, the module level boards. And then you'd have to change the firmware on the BMS to so that it knows that it's a 70 pack instead of an 85.
Yeah.
Now, do you find that if it's a low capacity situation, do you find that it's because the connection for some of the cells in the brick have actually been burnt or disconnected, those little fusible links, or is it the actual cell is starting to fail?
No, it's usually, a lot of the time it's cell failures. I don't think I've ever seen a module where it has blown the fusible links blown. I don't think I've ever seen one like that.
Was that
yeah. I'm sure there's situations where people have seen it before, but I think that's pretty rare. Usually what it is it's a cell that essentially the chemistry in it has gone to a point where either it's really low capacity or it's a parasite. It's become basically a resistor that's pulling power out of the cells around it.
Got it. And one more thing about the batteries, and then I'd love to see what you got going on in your bench and some of the shop tour. That'd be pretty cool. When it comes to Talik, can we blame him in some way? Is it because of his driving? What did he do to this Model Y?
Well, before we get into Alex's response to that, my own assessment would be more, it's not my driving, it's how little the car was resting to balance.
Oh, really?
That could be a part of it, but if it were a healthy battery to start with, it shouldn't have been a problem in the first place. It probably had, maybe a cell or a group of cells from a bad batch that, just took some amount of time to come up as an issue. And usually it's, relatively low mileage where that thing kind of pops up. What kind of mileage was your first pack replaced at?
Well, I would actually love to talk about this in depth. I can give a couple. It would be great to do a whole battery talk about my situation. But anyway, my first pack was replaced. My original pack was 40,000 miles. It had a BMS A066, and then my first replacement remanufactured pack after 20,000 miles of driving had the same exact BMS A066 problem. And now I'm on my third pack for 60,000 miles. And so far, hopefully it's still okay now that I'm out of warranty. But I've been talking with Johnny and other people about, how to make sure it doesn't happen again, at least with whatever's in my control beyond faulty cells, like you said.
Right, yeah. Yeah, I would say that, the driving style can play a factor, but I think overall it's more likely that the battery had some physical issue with the cell that, letting the car sit and be able to balance can help it. But at the same time, if it has an actual problem and it keeps rebalancing itself like that, it ultimately just doesn't pop up until later on. So it was probably a pre-existing issue that popped up early enough that,
man, we can't blame Talik for this.
I can tell you the original owner of my car used it for Uber full time. He drove it about 80,000 miles a year for 5 years straight. And the original battery that lasted 250,000 miles. So, that car was probably supercharged once or twice a day, almost every day for years.
Yeah, I've been hearing all sorts of things like the 18650s were just better built in general. A lot of people in the forums are saying the 2170s are not as high quality, depending on what batch you get and whatnot. And yes, there's on my out of spec video about my battery, there are tons and tons of comments saying well, this is why you can't supercharge every day, even though that's not what I did, et cetera, et cetera. So anyway, I'd love to do a more in-depth video about that. Let's see the shop.
Yeah, let's go to the shop. Cool. So what are you working on? What's on the bench? Can you tell us?
Let's see. Do you want me to take you out there?
Yeah, let's do it.
All right. Let me turn my camera around here. You'll have to excuse the mess. I'm still trying to get stuff kind of moved in here. Trying to get stuff organized and whatnot.
How long has the shop been open?
So I just moved in here. I think it'll be 3 weeks tomorrow.
Oh, wow.
So I just barely moved in. But yeah, you see I've got a Fiat 500e in here. And then I've also got a Toyota Rav4 EV. Wouldn't be QC Charge without a Rav4 EV.
Nice.
And this one is actually the one that I'm doing the contactor repair on. So I have the pack opened up here. These are actually the old contactors, so you see how that one's all burned.
Oh, yeah.
Oh, wow. That's not just the color of the plastic. That's from a burn, right?
That's what it looked like originally, and that's the one that burned.
So those look
And so
like backs, though.
And so I replaced that with a set of Gigavacs here. So there's
Those
the two
were
new
Tychos.
contactors.
The white one was a Tycho.
Right. Yep. The Tyco. The white ones are the old Tycos. TE.
So everybody that's watching right now, so the recording will be picking up the full screen of just him talking. But if you want to see bigger, go ahead in the actual settings right now and you can manually make him the full screen on your video right now.
Just click the pin. There's a pin icon.
So these modules, they probably don't look too familiar with these covers on them. But if you peel the little cover back, looks just like a Model S module.
Yeah.
They're just a slightly different layout. So the Rav4 pack is a little bit freakish. It's 92S, and it has 6 of these 12S modules. So there's 5 on the bottom and then 1 stacked on top in the back. And then it has 4 of these 5S modules that make it all up. So it's kind of a weird, freaky conglomerate thing. But it's set up this way specifically
when the lid goes on, it's actually stamped and it follows the contour between the modules, and it fits right in the floor pan, like where all these structural members are. The
Oh
battery
my
fits
God.
around all of that.
So how much does the regular RAV4 share with the RAV4 EV?
So all the, I mean, the body and the suspension and all that stuff's the same. There's a lot of stuff that's shared. I mean, your rear subframe here is the same. Here's your mounts where the rear differential would go on an all-wheel drive gasser. It even has the exhaust hangers. So there's an exhaust hanger there, and then there's more exhaust hangers here.
So in theory, you could actually take a regular RAV4 and find a wrecked RAV4 EV system and convert a RAV4 to RAV4 EV somewhat OEM-y, right?
Potentially, yeah. I mean, there's certainly some things that are different. Like, I mean, the hardest part to do would be able to get your mounting hardware for the battery in the rockers here. And there's probably a few other things sheet metal wise that are different. Like, I'm sure the sheet metal cutout where the charge port goes in the gas door is different. And of course, you have some of your wiring harnesses and stuff in the car that would be different. But in theory, yeah, you could swap it all in because it is really just it's a third generation RAV4 body. So the third gen RAV4 in this body style went to 2006 to 2012, and then they switched to the new body style. But the RAV4 EV stayed with the old body style for 2013 and 2014. So they actually had two different body styles of RAV4 on sale at the same time.
This is amazing. I'm so excited to see this.
And there you go. There's your Tesla large drive unit. This one's got our drain system on it, so it has the coolant drain sump and everything. That's what all the little lines are for.
Wow.
And this one's going to get our rotor cooling delete as well while it's here. And then yeah, over here, this is the large drive unit I mentioned earlier that used to belong to Ray Johnson of the BMSU 029 group. He runs that group, but this is his old drive unit. So that's a sport drive unit out of, I think his car's a 2013 P85. And then, yeah, this right here is our coolant delete manifold.
Oh, cool.
So that's what eliminates those problems.
Is that anodized aluminum?
Yep. It's machined out of a solid block of 6061 T6. And so this is actually set up for dual purpose. Originally, when we were designing this, the original intent was to do an oil-cooled rotor conversion. And this part is capable of that. So all these little extra plugs on here. And then you can see it actually has some extra machining done on the inside. It's set up so that you can do oil cooling for the rotor. But in the case of what we're doing for most of these, we're just installing this as it is and just deleting the rotor cooling. It's actually kind of a little bit of a copy of Tesla's newest large drive unit revision, which is the Revision U, where they have started doing the rotor cooling delete on their own for replacements. And that's actually what Ray got here when he had his drive unit replaced. He got the new rotor cooling delete revision. It's only been out for about 4 or 5 months now.
How did they let him keep his old motor there?
That's a good question. I've heard of a few situations where if people ask, they'll let him take it, and other times they don't. He just asked, and they said, sure, you can have it. So, yeah, he was able to just keep it. So anybody out there that gets their large drive unit replaced on your Model S, especially if it's still functional, ask if you can keep it. If it's been flooded with coolant and everything, there's not a whole lot that can be salvaged. But if it is a functional drive unit, it does have value. And this one will just get rebuilt and reused for somebody else's thing. But yeah.
So early, we were talking about how like up until 2020, the LDUs have all the same problem. Has anyone put the newer LDU in an older build to replace the bad problem?
Like a newer, so all LDUs have this problem. So past 2020, Tesla didn't put LDUs in cars anymore. So 2020 was the last year that they had the legacy Model S and Model X. And later on in the year for, late 2020 was when they came out with the new generation, the Plaid, and they call that platform the Palladium platform. So that's the Plaid and the new generation long range. So of course the Plaid is the new performance version, which doesn't use the large drive unit. It has a tri-motor setup instead of using a large drive unit in the rear. So yeah, that's the cutoff, is when they stopped using the large drive unit for new production cars.
So what's in the rear of the refresh long range Model S?
It's basically just a small drive unit. So
Okay.
to my understanding, it's actually the same small drive unit that was used in the previous long range Model S. So yeah, it's just not an issue if it's just a regular dual motor long range car.
In theory, can someone take those newer or just another small drive unit and replace their LDU with a SDU?
No. Well, it depends. So if you have a dual motor performance car, the answer is yes. You could convert it to a regular non-performance dual motor car. But if it's a rear wheel drive car, you're stuck with the large drive unit. You can't put a small drive unit in to replace it. There's not a firmware package or anything that exists for that.
Cool. Well, let's get back to the shop. What else you got for us?
Well, that's kind of the main stuff that I have right now. I guess I can show you some of my special tooling stuff. So, of course, I have motor stand here. So this is set up specifically just for rebuilding the large drive unit. So the motor end clamps right in here.
Item?
What's that?
Send, cut, send. That looks good, man.
So the engineering work was my design, so that's all done in Fusion 360, and we had a fabricator who's in San Marcos that does all this stuff for us, and he does fantastic work.
Wow, it's cool looking.
But yeah, it's all just cut sheet metal parts, all welded together, and it's a Harbor Freight engine stand that's just been modified to accept all this stuff. And yeah, so the large drive unit just clamps into it, and it's set up specifically so that when it's in there, it's right on the center of gravity. So you could spin it without it, trying to kick one way on you. And yeah, and then it's got the drip tray and all that good stuff. We have a few revisions we want to do for the next ones that we build, but it works great.
Nice. That's an important detail right there. This is the new auto shop. We're basically looking at the future of automotive technicians right here, of independent shops.
Yeah, I mean, we've certainly had, interest from folks that build tooling and stuff for automotive shops that have come to ask us questions. I don't know how much of that I can really share, but we've had multiple different vendors that came to our San Diego location with, basically questions about the kind of stuff that we built and that sort of thing. So anyway, yeah.
Well, that's probably a pretty good segue into wrapping up tonight, because our last few questions are basically, what training should people have before converting, which I think we've kind of touched on a bit. And you kind of already talked about the training you had at the beginning of the video. But where do you see this industry going? Like Ron said, this is like the future of repair shops here. But where do you see this all going?
Yeah, so I mean, the future is definitely that there's more and more of these cars on the road all the time, and the older they get, the more repairs they're going to need. That's just the nature of cars, right? Anything mechanical is going to break down eventually, and there's kind of a shortage of people to fix them. Even right now, as we're ramping up into more and more adoption of EVs, there's such a shortage of shops to work on them that it's actually a little bit of a problem in some cases. Like, I mean, a lot of people with these Model S's and things are shipping their cars across the country to have shops work on them because there's nobody in their backyard that can fix them. And, the same is the case for cars like the RAV4, where we were having these cars shipped to us, from across the country and even internationally to work on them because nobody else did. So there's a need for more people to be trained to fix these cars, and yeah, that's kind of what it boils down to. Looks like Tom had a question.
Yeah, Tom, go for it.
This is just really exciting. And to talk about, shops, man, I'm not at liberty to disclose too much right now, but we are applying for a multi-million-dollar grant. When I say we, I'm talking about the EV Learning Center, and in conjunction with a really big nonprofit outfit that is involved with workforce development. And part of our grant writing is we're going for a 4-bay, 6,000 square foot facility and a regional training center program for a certification for EVITP. Yeah, a new 5-letter acronym to me anyway, which stands for Electric Vehicle Infrastructure Training Program, which is going to be a certification requirement for people who plug in big, heavy, high voltage things, like ships. Obviously it's more than just plug and play when you're talking about wires that are as big around as your leg.
Yeah.
Right. Yeah,
Well,
for sure.
Tom, so we could do like more in depth on this, maybe on the next episode. We're kind of hitting the time limit, with everyone's time here, and we're trying to keep the videos short so they're more watchable. And but this is exciting stuff. So EVLC is growing, and so is the industry. Clearly, Alex and QC Charge are growing. They're expanding to other areas. So it's very exciting times. I know that, off-grid systems, we're doing, I'm doing that in my high school class right now, and we got a lot of people interested. So very cool stuff. We can kind of wrap up. I think Kevin also probably had a question, but maybe we'll get to it next time about how do you diagnose and how do you talk to the OEM manufacturers? Is there like diagnostic equipment? Kevin, you probably wanted to ask that.
Yeah, I just want to throw it out there that, just because these cars are all computerized and everything doesn't mean you can't work on them. So for that Fiat there, Alex and I were talking about earlier this program called Alpha Scan. What's it called?
Alpha OBD.
Right. And it does a bunch of diagnostics for the Fiats and other cars. And I bought the paid version of it. Even the free version does a lot, but the paid version does a whole lot more. You can run through some of the car's self-diagnostic tests and all this stuff to be able to fix your car with your cell phone as the diagnostic tool. There's a similar
website right here.
Looks like that.
Yep. Yeah, that's the site for it. Yeah, that's correct.
Yeah. And what I was recommending to Alex before is you use these OBD dongles that plug into the OBD normal diagnostic board of your car to interface and buy a better one. They're $10 on Amazon for the cheap ones, but I bought a better one, which I think will give you less trouble. There's similar programs for Tesla, I know too. There's Scan My Tesla, which will give you the health of your battery and all kinds of information and let you run through some diagnostic tests as well. So look out there and see what's available. There's lots of forums out there. Facebook is a great source for these. There's a fan club for every obscure thing you can think of on Facebook. So you'll find the information there. And there's also people that can help you figure out how to use some of these tools, which can be complicated.
Very cool. So
yeah, there's so many enthusiast groups that come up with different options for being able to do this kind of thing. One of the oldest examples of one of those kind of apps is called Leaf Spy, and that was developed, I don't know, probably 10 years ago, back when the Leafs were still basically new, and they've continued to update it and keep its capability, but it'll even allow you to do a battery swap and reprogram the new battery to the car as just like kind of a hot button function in the app, which is pretty cool.
And enthusiasts have just reverse engineered the car's CAN bus to go figure out how to do this. And none of this is allowed, permitted, or helped by the OEMs, but it's all been figured out. And I was very involved with Leaf Spy and met with the guy who created that app a few times. And I had leaf logger website up that would take the information from that app actually and publish it to a website so you can analyze your battery usage and car's performance.
That's really cool.
Yeah.
Well, in the interest of time, I mean, there's always so exciting at the end of these sessions. Interest of time, we'll wrap up the recording here. We're going to have some people on next week that are involved with EV racing on budgets. And I just think I want to shout out to everyone in here who's given it a shot, trying their hand at the EV thing. It's such a cool thing that we have this community. I feel lucky to be a part of it. We got great people in the house, community organizers like Tom. We got Jonathan Knight, John Lane, Chad, Brad, Brian McCabe, Adrian. All these people are going to convert their car over. And you got Kevin Lieberman diving into the software deep end. He don't care. He just dives right in that deep pool. And then we got great people like Alex willing to share information and give us like a tour. I really appreciate you being here, Alex, and Talik being a co-host and keeping his finger on the pulse out there. Look out for Talik's videos. So cool. So anyway, that's just to wrap it up. Any final thoughts from people, and we'll just kind of wrap it up and leave it here. All right. Yeah, that's pretty good. Okay, so tune in next week and bring your project questions. If you have a project, don't feel like you're doing this alone. Jump in and let us know what's going on, and we want to be able to help you, because I don't know everything. So we got to talk with people like Alex and Kevin and and all these people that are doing the deep work. So thank you, Alex, and I hope to get north one of these days. I really like it. I went up to Eugene, and I kind of like it up there. It's weird. It's beautiful, and then it'll like rain for 5 minutes, and then you're back to beautiful again. It's like Vermont and Florida are like together.
Good
So,
way to put it.
all right. Well, thanks a lot, Alex.
Yeah, thanks for having me on.
Thanks, Alex.
Okay.
And everybody check out
Thanks.
Talik's video, the Crown Vic video. It is so good.
Oh yeah, I forgot to. I can finally say it's live. It is on. It is finally published on Out of Spec Renew. Tim Allen's 1934 Vic. Check it out.
Yeah, you gotta look for Todd's video, Charge Positive and Out of Spec Renew, and obviously I'm Mr.G, and there's a lot of people that are making this all possible. So all right, see you guys next week.
Thank you.
Have a good